Hi friends, today we're going to talk about graphing quadratic functions in standard form. So as always, we're going to start by writing down our a, b, and c. So here a is 2, b is 4, c is 3. Our first step is going to be to find the vertex. So remember the x value of our vertex is b divided by negative 2 times a. So the x value of our vertex then is 4 divided by negative 2 times 2, which means the x value of our vertex is negative 1. To find the y value of our vertex, then we plug negative 1 into our original function. Make sure you put it in parentheses. So 2 times negative 1 squared plus 4 times negative 1 plus 3 gives us a y value of 1. So our vertex is at negative 1, 1. I'm going to graph that first and draw in my line of symmetry. Next, we're going to find the y-intercept. Remember, our y-intercept is our value of c. So in this case, our y-intercept is at 0, 3. I'm going to plot that and plot the reflection. The y-intercept is 1 away from my line of symmetry, so I'm going to go on the other side. And then I need to find one more point and its reflection. Remember, you want to pick a point that's close to the vertex, but not a point that we've already used. Our vertex or our line of symmetry is at negative 1 here. I can't use 0 because I already have a point at 0. So I'm going to go one more to the right and do when x equals 1. Plug that into my equation. So when x is 1, y is 2 times 1 squared plus 4 times 1 plus 3, which means the y value of my second point is 9. So I have another point at 1, 9. So I'm going to put that point on here. That's 2 away from my line, so I'm going to go 2 on the other side of my line of reflection. And now I have my 5 points that I can connect. We'll put our arrows because it keeps going on forever. And there's our graph. Let's go to another one. Here, a is 1, b is 2, c is 4. So for our vertex, the x value of our vertex, b divided by negative 2 times a, which ends up giving us negative 1. For my y value, I'm going to plug negative 1 into my equation. Negative 1 squared plus 2 times negative 1 plus 4 gives us a y value of 3. So our vertex then is at negative 1, 3. I'll graph that. Draw in the line of symmetry. The y-intercept then is our value of c, which is 4. So our y-intercept is 0, 4. So let me put that on my graph and its reflection. To pick another point, again, 0 has already been used, so I'm going to go one more to the right and do 1. For my other point, I'm going to do x equals 1. So plug that into my equation. 1 squared plus 2 times 1 plus 4. That gives me a y value of 7. So my other point then is at 1, 7. That's 2 away from my line, so I'm going to go 2 on the other side of my line. Now I have my 5 points. I'm going to connect those. Don't forget the arrows because it goes on forever in the positive direction. Let's look at one more like this. In this case, a is negative 3, so I know my graph will be upside down. B is 6, C is negative 2. For our vertex, our x value is b divided by negative 2 times a, which gives us an x value of 1. Our y value then, I'm going to plug 1 back into my function. Negative 3 times 1 squared plus 6 times 1 minus 2 gives us a y value of 1. So our vertex then is at 1, 1. We'll draw in our line of symmetry. Next, we'll look at our y-intercept. Oops. Again, the y-intercept is our c value, so our y-intercept is at 0, negative 2. And I'll plot the reflection of that. As I can see, it's starting to open upside down here. Let's do one more point. I know that my line is at 1, but I already have a point at 0 and I already have a point at 2, so I'm going to go one more away from my line and put in 3. Oops. So negative 3 times 3 squared plus 6 times 3, take away 2. And that gives us a y value of negative 11. So I have another point at 3, comma, negative 11. That's 2 away from my line of symmetry, so I'm going to go 2 on the other side of my line of symmetry. And now I have my 5 points that I can go ahead and connect. I know I did it correctly because it's upside down and my line of symmetry is right in the middle of my points. The other thing you need to know how to do is if you're given a graph and you're given the values of a and c in the equation, you have to find the value of b. So we're going to use the fact that the x value of our vertex is b divided by negative 2 times a. Since we're going to use that to solve an equation, we're going to write it like this, b divided by negative 2 times a. If I look at my vertex here, it's at 2, negative 4. The x value of my vertex is 2. My a is 2. I don't know my b. My c is 4. So now plugging in what I know x is 2. I don't know b. I know a is 2, and then continuing to simplify, negative 2 times 2 is negative 4. And then to get rid of the divided by negative 4, I need to multiply both sides by negative 4. They cancel here, and I get that b is negative 8. Let me show you one more like that. In this case, a is 1, b is question mark, c is 0 because I don't have anything added on. That just means the y-intercept would be at 0, 0. Our vertex is at negative 2, negative 4. So the x value of our vertex is negative 2. Again, we're going to do x equals b divided by negative 2 times a. So negative 2 equals b divided by negative 2 times 1. In this case, a is 1. Continuing to simplify, negative 2 equals b divided by negative 2. And then we'll multiply both sides by negative 2 here. Those cancel, and b equals positive 4. All right, that's all I have for you today, friends.